Hello and welcome back to the data integrity lesson. In the previous topic, I introduced Alcoa Plus. And now we turn our attention to the FAIR principles. We touched on the FAIR principles already in the first topic, and you might remember that it stands for Findable, Accessible, Interoperable, and Reusable. FAIR is kind of the more famous brother or sister of Alcoa. Why more famous? Because it is more widely used and much more talked about. For example, this nature comment, "make scientific data fair," refers to the geological sciences, where FAIR is applied. You might want to have a look at this book by Hansen and colleagues, which explains the FAIR data principles with a fictitious story about elves looking for treasures, which are the research data, and the troubles they have to locate and use them. Here's an example where the FAIR principles are in use. This is a screenshot from an EU grant app template requiring applicants to comment on each item of the FAIR principles and how they will be achieved. Let's briefly look into FAIR and what is behind the acronym, which appears obvious. However, a short disclaimer, we will only scratch the surface here. The actual principles are more detailed. Findable, not surprisingly, means that it must be possible to find the data. This is not always trivial, and FAIR even requests that there is a global unique identifier. This indicates nicely the difference between FAIR and Alcoa. FAIR has a focus on published data, as it is very difficult to achieve a global identifier for each experiment. Additionally, findable also means that data should be findable by humans and computers. And this is important if you think of text mining or carrying out automatic analysis for systematic reviews, as described in one of the previous presentations. The second letter stands for accessible, which is very similar to available in Alcoa. Here it's important to describe, or at least understand, the path from which data can be accessed. However, FAIR also requests that barriers like authorization and authentication should be considered and overcome any barriers that might block access. This is not mentioned in Alcoa and brings another level of transparency. The next letter in FAIR stands for interoperable, and this refers to integration with other data and systems. That means that data sets can be used across different labs, and one of the main challenges here is the naming. So this is asking for a unified naming convention, meaning that there should be the same identifier for the same item across labs. An easy example from in vivo research. Some labs write M, others write male, and another lab might use the gender symbol, circle with an arrow. All mean the same thing, even though it might be easy for humans to understand and make the connection what is meant in each case. It makes it impossible for digital systems to understand. In such cases, data are not interoperable. The other aspect of interoperable is also at the application and equipment level, when different hardwares and file formats are used. This was, for example, an issue with Mac and Windows computers. The last letter of FAIR stands for reusable, and this refers to the data package that comes with the actual data, which is also referred to as metadata. Here again, there is an overlap with Alcoa. It is basically saying that you need to describe your actual data with enough supporting data to be able to read and use it. For example, when you are collating your raw data in a table, part of the metadata would be simply the names of the columns and rows. You absolutely need this to be able to process and understand the data. But of course, it doesn't stop here, as it should also include equipment, settings, for example exposure times, and other important information to understand the experiment and the data. This last slide is a summary of the abbreviations that make up Alcoa Plus and FAIR. I hope these two principles can provide some guidance for you when thinking what and how experiments should be documented to ensure data integrity.